Hello, Mrs. Dewey. This is John, and today I am going to give you the second video assessment problem, which deals with finding the derivative of a graph function. Now here, you gave us a graph that appears to have multiple types of functions inside of it. The way I just figured out to find the derivative of the graph was to break up the graph into different sections. Now, the first part I looked at in the graph was the far left side, which appears to be a linear graph with a negative slope. Now, to find the slope, which is also the derivative of a linear function, I first found 2 points and found the rise over run, which found that the rise was plus 2 and the run was minus 2, meaning that the slope was negative 1. So the first line of the derivative would be at y equals negative 1 with a step discontinuity at x equals negative 3, as in the original graph, when x equals negative 3, the function appears to change. Now, the second part of this graph shows to also be another linear graph, but the slope appears to be positive. So, to find the slope again, I found 2 points with both rise and run being 1 unit, so the slope is 1, meaning that the derivative would be at y equals 1. So, I put the line at y equals 1 with 2 discontinuities, one at x equals 3, which is from the previous derivative, then to show another change in the graph at x equals negative 1. The next part of the graph is a horizontal line, meaning to find the slope, rise over run, you find that the rise is 0 and the run is actually changing. Now, for any slope, it's always a rise over run, and since the rise is 0, anytime in a fraction, the 0 is in the numerator, the slope is always 0. So, meaning the derivative of this function at this point would be 0. So I've plugged the derivative in at y equals 0, and then adding the 2 step discontinuities at x equals negative 1 and x equals 3. Finally, we have the last section of the graph, which is a quadratic formula. Now, this is a little more different to find the derivative. What I first did was I found the minimum or maximum point of the function, which in this case was a minimum, and plugged in 0 for the derivative. The reason why I plugged in 0 was that for the original graph, as the slope reaches that minimum or maximum value, it reaches closer to 0. So the point would be 0 as it reaches that point. Next, I plugged in the step discontinuity at x equals 3, and then from there, I used a ruler to connect those points and continue the line as the graph is continuous at this point.